Welcome to our third lecture on general chemistry. Before we start, however, I'd like to just review a few of the highlights of the last lecture. We looked at chemistry and, of course, the definition of chemistry. And we also looked at matter and a definition of matter. And we looked at the properties of matter and the changes of matter. Remember that the properties of matter are physical and chemical properties, and the changes that matter can undergo would be a physical change or a chemical change. So as I pointed out in last lecture, you should not only know these definitions, but you should be able to apply these definitions to solve different problems. For example, if water is boiling, is that a chemical change or is it a physical change? Next, we looked at scientific method of solving problems, and as a scientist, how we solve problems. And some terms that are very important are fact, hypothesis, and theory. So again, know what these terms are, but not only knowing what they are, but you should be able to apply them. So given a particular statement, you should be able to tell if it's a fact, an hypothesis, or a theory. Next, we looked at scientific notation, also known as exponential notation. So again, your calculator here will be very helpful. Make sure again that you purchase a calculator that can do scientific notations. You will use that calculator quite a bit in the first part of this course. And next we looked at measurements in terms of the precision of measuring. In other words, your measuring device gives you a aspect of the precision of that measurement. And lastly, we looked at significant figures and decimal places. So again, know those definitions because you'll use them whenever you carry out various calculations. Okay, so let's go into today's lecture. And what we'll look at today is essentially measurements in the metric system. Key here is metric system. As scientists, the system that we use is the metric system. So when you go to lab and you are asked to determine the volume of something, you will not report that in terms of quarts or fluid ounces. You will report that in the metric system, and the unit for the metric system of volume, as you can see here, is liters. So just to go over this, the length is not in inches or feet, but the unit that we'll use is meters. Mass, it won't be in pounds pounds, but it will be in grams. As we'll see later on, we have another term, kilograms, depending on how many grams they are. Time, we are familiar with that, and that's the same in the metric system or the English system, or the older system. Temperature, though, temperature is interesting because the one that's used most frequently is the Kelvin, which we'll define in a second, but also used is degrees Celsius. I know we're very familiar with degrees Fahrenheit, but in this course you will see mostly degrees Celsius. And see, energy, which we'll define, is the unit is joules, and we'll use this quite a bit. The amount of substance, it's not in terms of pounds or grams, the amount of substance that will use, the unit that will be used is the mole. Don't worry too much about that just yet, because we'll have to define that, and then you will know when to use it. So from this overhead here, the main aspect here that you need to concentrate on is length is in meters, volume is in liters, length is in meters, volume is in liters. Did I say that right? Length is in meters, and volume is in liters, and mass is in grams. And of course, temperature will be in Kelvin. Okay, as I mentioned earlier, you have grams. You know you have grams. You're familiar with the saying grams, and you're familiar with the saying kilograms, or meters and kilometers. The point here is that a kilometer is a lot larger than your meter. So we have different prefixes that are used. So let's look at some prefixes that are used to express different quantities. The one that we're most familiar with or most used here will be kilo. And of course we'll put a K. And of course that's 10 to the third. Here's your scientific unit again, scientific notation, and that means 1,000. Another one that we'll see frequently is centi, and that's 10 to the negative 2 or 1/100th. Another one that we'll see is the milli, which is 1,000th or 10 to the negative 3. So as you can see here, that scientific notation is used frequently. Especially if you're in the medical field, you'll see this quite a bit, micro. And that's the Greek letter that's used to represent micro. So microliter here is 10 to the negative 6 or 1/1,000,000th. 10 to the negative 6. Look how many zeros we have here. So to avoid using that many zeros, we use the scientific notation quite a bit. Okay, let's see if we can apply that. So in applying what we did on the previous slide, let's see, a good question here is, how many kilometers are there in 1 meter? So what we're asking you basically is, did you understand the previous slide? And can you use that information now to convert 1 kilometer into millimeters, or how many kilometers are there in 1 millimeter? Okay, so what you may want to do is pause the video for a second and do that calculation. You may even want to go back and see what that table represents and come up with an answer. Before I show you the answer anyhow, let's look at another one, microliter. And I included this one specifically because I know a lot of you students are in the medical field, and you'll have very small quantities. Very small quantities. You guys use very small quantities in the medical field, and you can see here it's typically referenced as microliters. So the question here is, how many microliters are there in 1 liter? How many microliters? You'd expect that to be a lot. Okay, so do the calculations. You may want to go back again and look at that table and see if you can make that conversion or that comparison. Okay, so the next slide has the answer. And as you can see here, this is 10 to the negative 6. Again, let's see if that's reasonable. A kilometer, as you can see, a kilometer here is a very large unit. And a millimeter is very small. So you'd expect to have a small number of kilometers in a millimeter. And this is a reasonable answer. Let's look at this other one, however. A microliter is very small, microliter. So how many are in 1 liter? You'd expect a lot. So again, whenever you ask to solve these problems, a lot of times you can use intuition, we call it chemical intuition, to look at the possibilities here and make a determination. How many microliters? very small quantity or in a very large volume here. So you'd expect a lot. So you can see that this one here is a very small number, so that would not be a good choice. This is another small number, not a good choice. So we have a possibility between these two here. So what you'll have to do is to look at the previous table that I gave you and make that determination. So again, you'll have to be able to apply that knowledge. Okay, let's continue. Now what we look at here is measurements. Measurements, as you know, in chemistry and in science, especially in the medical field, again, we have a lot of measurements that we have to deal with. Well, in everyday life, you have a lot of measurements that you have to deal with. Main thing here is that it consists of two parts: a number, and equally important is the unit. So whenever you ask to solve a problem, you need to give units. All right, let's give an example here of the importance of units. If you're asked to give the weight of something, you do not just say it is 60, for example, and no unit. It weighs 60. Okay, but what you say is 60 pounds or 60 kilograms. So here's your number, and here is the unit. Okay, also written as 60 kg, kilograms. And see. Another example here is if you were asked, what is the temperature outside? You do not just say, well, it is 100. Okay, it could be very confusing, especially to us scientists. Very confusing because, as you can see, we have different units. So if you say 100, it doesn't mean anything, but you may want to say like 100 degrees Fahrenheit. Then we can get an idea of how hot or how cold it is. Of course, that's a very hot temperature for the weather. Or we can say it's 30 degrees Celsius. Again, pretty warm. But again, you need these units here whenever you give a measurement. Let us continue. What we'll do here is we will do some conversion. As you can imagine, we'll have to convert because we're living in, especially here in the US, where we use different systems. For example, if you went to put gasoline in your car, you do not fill up using X amount of liters. You say you have like 8 gallons of gasoline. You go to buy something, you do not say you need 1 kilogram of something, but you need 5 pounds something. So since we're scientists and the units that we'll use is the metric system and not the English. Okay? But a lot of times we communicate using the English system, so we'll have to convert the English system into the metric system. And sometimes vice versa. So what we have here is what's called conversion factors. Pay special attention to that word, conversion factors, because that is the factor that you will need to make the conversion from one system to another system. For example, 1 inch is equal to 2.54 centimeter. That's an important conversion factor. Let's just quickly go through this. The mass, 1 ounce, is equal to 28.35 grams. And of course, the volume over here is 1 quart is equal to almost 1 liter, 0.946 liters. So again, these are called conversion factors. You will need these conversion factors or a conversion factor each time you convert from one measurement to another measurement, which would be in a different system. Let us see how we apply that. So again, as you can see, I am big on application of knowledge. So here's a basic knowledge here, and when you take your quiz and on the test, have this available. You may not use it because I will give you the conversion factors, but you'll have to be able to utilize that information. So let's see an example on the next overhead here. So let's see if we can do this. A conversion factor, as I mentioned earlier, is a ratio between two different units, and that's used to convert one system to another. Let's look at an example. This is just an example, so you should be able to utilize this, to look at this example, understand this example, and utilize it as an example for solving the problems of others. Convert. Notice the key word here is convert 381 grams to pounds. So we're doing the reverse now. We're taking the metric system in grams and converting it into the English system, pounds. So in other words, your answer should be X pounds, or some weight in pounds, because what you're given here is the weight in grams. You need the conversion factor. 1 pound is equal to 453.6 grams. You will always be given this. If it's not given, you ask for it, because that's the only way you can make that conversion. To make that conversion, you'll have to set up your equation like this. Notice this is the conversion factor. 1 pound over 453.6 grams. What's given here is 381 grams. So here's the unit. Here's the aspect of importance. The grams here will cancel grams here. So units cancel just like numbers. If you cancel the grams here and here, what you end up with is pounds, and that is the answer. So now all you have to do is go use your calculator, type in 381, and divide that by 453.6. And this will be your answer reported to 3 decimal places. Okay, make sure you can do that. What I've done on the next slide is to reverse it on you to see if you can make the conversion the other way. So let's see that. So here we have, now let us convert 381 pounds to grams. Okay, 381 pounds to grams. And I want you guys to think about that question carefully, because it's just the reverse. It's basically making sure you can apply this information. So the conversion factor is here again, same conversion factor, because you're converting pounds to grams or grams to pounds. So the same conversion factor you will use. The trick is, how do you set up your conversion factor? Now you set up your conversion factor so that the pounds here cancel out. And when you, after you finish your calculation, you end up with grams. So again, make sure you set up your conversion factor so the units cancel to give you the unit that you're trying to get, or the unit you're asked to calculate. So in this case, you get your calculator. Now you type in 381, and now you multiply by 453.6. And this would be the answer that you would get on your calculator. Notice it's a large number, so we use the scientific notation. We do not use a lot of zeros after that. We just use the scientific notation here, 10 to the 5th grams. So before we go on, I just want to reinforce that you should in fact be able to use a conversion factor here to calculate or convert from one unit to another. This is just one example. As I said earlier, We have different ways of communicating measurements, pounds, we have grams, we also have liters, we also have quarts and gallons, and so we're constantly doing conversions. Let's see. So here's some examples on the next overhead here. So let's see if we can apply this. So the length of an American football is 100 yards. 100 yards. Notice I'm underlining my key aspects here. 100 yards. And which of the following approximates the length of this in meters? So what we're asking you here is to convert 100 yards to meters. So again, whenever you read your questions, sometimes a lot of wordings are listed, but pull from that what's being asked. Sometimes you may have to read your question more than once just to make sure you understand what's being asked. And that's good as a scientist, because you need to understand what's being asked before you can provide a solution. So what this question is asking, 100 yards, convert that to meters. You will need a conversion factor. So I will give you the conversion factors whenever I ask you these questions. Of course, if I don't give you, you have it in your notes. And of course, when you're taking the quiz and your exams, you can use your notes to look up these conversion factors. But that will take time. So you'll lose time in terms of doing the test. So, but I will give you the conversion factor. So here's the conversion factor. So what you need to do here is to decide how you will set up this conversion factor so that after you've done, the yards are cancelled out and you end up with meters, which is the units over here. So once again, pause the video here, get your calculator, and do this calculation, set up your conversion factor, and do the calculation and see if you get anything that matches over here, and that would be your answer. So again, pause it here. Okay, my next slide shows the answer. So here's what I got for the answer here. It is this one. And you can see that's reasonable because 100 yards. And we know that 1 meter approximates almost a yard. But it's a little more, so you'd expect it to be a little less than 100. So this is a reasonable answer. Notice the units. It's a number and the units. So that's the way we will report our measurements from here on. Okay, let's continue and look at another conversion, another measurement, set of measurements here, and this is temperature. As I said, in today's world, we have 3 different units for temperature. We're more familiar in the US with the Fahrenheit, F. So we ask, what's the temperature outside? We say it's 81 or 91 degrees or 104 degrees Fahrenheit. We're so familiar with Fahrenheit, so sometimes we do not even give a unit. We just say 100 degrees. And we expect that folks think that it's in Fahrenheit. But it doesn't necessarily have to be, especially in science. So you always give a unit. And that's defined as the freezing point of water is 32. Of course, we know that. We're familiar with that. And the boiling point of water is 212. A unit that is more familiar with scientists and that's used more frequently in Europe is the Celsius grade for temperature. And on this scale, the freezing point of water is now 0 degrees centigrade or Celsius. And the boiling point is 100 degrees. So your job now becomes, if given the temperature of today, for example, is, I don't know, 100 degrees Fahrenheit. What would that be in Celsius? What that requires is a conversion factor. So here are your conversion factors. This one converts Celsius to Fahrenheit, and this one here converts Fahrenheit to Celsius. Those will be given. You just have to learn how to use them. Okay. Here's another one that we'll use more frequently in chemistry than outside of chemistry, and that's the Kelvin. That's the so the Kelvin here, 0 degrees Kelvin would be absolute zero. That's the coldest temperature that anyone can get to, or any atmosphere or anywhere can get to, is absolute zero, which is 0 Kelvin. And the conversion factor is right here. You can see it's in K, so K. And of course we have degrees centigrade plus 273. So you have to convert to centigrade. You have to have the degree given in centigrade and convert it to Kelvin using this formula. Before we get further into that, however, let us concentrate again on Fahrenheit and Celsius with their conversion. So let's look at the next slide and see if you can do this one. So here we go. What is the temperature on the Celsius scale of normal body temperature of 98.6 degrees? Of course, again, for you guys in the medical field, you know that's body temperature, and whenever you measure your temperature, it's 98.7, and you know that's normal. But if you were working in Europe or some other countries, they use the Celsius scale. So the question now is, what is that temperature in degrees Celsius? What's given here are the two conversion factors here. So you'll have to decide which one. We're converting to Celsius, so obviously you will use this one because you need Celsius as your answer. So what you have to do here is get your calculator, because this will be given, these conversion factors will be given on the quiz and on the test. What we want to make sure of is that you can use that information to solve a problem. So get your calculator, since you know that you will use this one here for your conversion. Why this one? Because it asks for Celsius, and this calculates for Celsius. So get your calculator, type in the Fahrenheit, which is 98.6, and then minus 32, and then you multiply that by 5 and divide by 9 and see what you get. The next slide has the answer, but I want you to calculate it first before I show you the answer. So pause the video again and do the calculations. Get your calculator and do the calculations and see what you get, if you get any that matches any of these here. Okay, the answer is, after you've done the calculation, you should get this one. Notice again, it's in degree Celsius, 37. So the body temperature is 37 degrees Celsius, or 98.6 degree Fahrenheit, or degrees Fahrenheit. So the take-home lesson from this is that you should be able to utilize one of these conversion factors depending on what is given and what's being asked to make a conversion. You can convert from Fahrenheit to centigrade, or you can convert from centigrade to Fahrenheit. So you will have to determine which one to use based on the information that's given and the information that's requested. And of course, you'll have to know how to use your calculator to carry out these calculations. Okay, let's see what's on the next slide here. I think I have some more examples here. An automobile has an 18-gallon gas tank. 18 gallon. So that means 18 gallons will fill up that gas tank. So the question is, if you went to the gas station and all was shown there is quarts and not gallons, how many quarts would be needed? Okay, so again, what you need is a conversion factor. Here's your conversion factor. 1 gallon is equal to 4 quarts. So you need to set up your conversion factor so that the units cancel. Gallons will cancel gallons. So what's left is quarts. And then, of course, you carry out your calculations. So now what you need to do is again, do the calculations, pause the video, and set up your conversion factor, and plug this number in 18 gallons, do the calculation, and see which one of these is a reasonable answer. Okay, so let me show you the next video which has the answer, and that is right here, and this turns out to be 72. As you can imagine, that's reasonable, because if 1 gallon is equal to 4 quarts, which is 4 times, so you just a matter of, so you know it will be more than 18 gallons of gas. Okay, all right, let's see what's next. I think I have here, well, this is another example here, a little more complex. A certain automobile has 18-gallon gas tank, the same automobile, I guess. What is it in liters this time? What is it in liters? The only information that you're given is 1 gallon is equal to 4 quarts, and 1 quart is equal to 0.496 liters. So you know you're given 2 conversion factors. So now you have to make 2 conversions. 2 conversions. You already know from the previous question to convert 18 gallons into quarts. And then you can now convert quarts into liters based on that conversion factor. So this is a little more involved, right? So again, pause your video and carry out this calculation. You may have to go back a little bit and cross-check your calculations, but the bottom line is, after you've done the calculation, you should get an answer over here that is consistent with all the other students' calculations, or the correct answer. So what I have here as the most reasonable answer is 68 liters. And that's reasonable, because 18 gallons, we know that a liter is a lot more than a gallon. So it's reasonable to have 68 as the answer. Okay, let's see what we got here. Okay, let's cover this other topic and then we quit for this lecture here. So let us look at the 3 states of matter. States of matter. Okay, so as we discussed earlier, matter is anything that occupies space and has a mass to it. We know they have properties, and we know they can undergo changes. One is a physical change, and the other one is a chemical change. Now we're looking at the physical change, which will change it from one state to another. Classic example here is water. You take water and you put it in the freezer. It becomes ice. So that's a solid state. So you're moving from a liquid state of water to a solid state. You take that water and you put it in a pot and you put it on the stove and you turn on the heat and it starts boiling and you see steam coming off. That is a change of state from liquid water to vapor water, or gas water. So let us define that, or those states, 3 states. Gas has no definite shape or volume. So just think here of steam. Steam has no shape or volume. Okay, or when you put gas or helium in a balloon, the helium acquires the shape of the balloon and the volume of the balloon. It expands to fill whatever container you have. Again, helium in a balloon, it fills the balloon. It is highly compressible, highly compressible. Okay, so in other words, if you take a balloon and you, with air, and you squeeze, you can squeeze it so that it becomes smaller, so it becomes compressible. Let's look at the other state, liquids. Again, imagine liquid water here, water at room temperature. It has no definite shape, but it has a definite volume. So you can measure here 100 milliliters of water. But you cannot say it has a fixed shape because it acquires the shape of the container. It is only slightly compressible. So in other words, if you start squeezing water, it does not change its volume a whole lot. The last form of matter is solid. So you can imagine your ice that you take from the refrigerator, from the freezer. It has a definite shape and a definite volume. Okay, so you take a cube of ice, it is a cube with a fixed shape, and it has a definite volume. So you can measure the volume by doing as we did from the previous lecture in terms of multiplying the sides of the cube to get the volume. It is essentially incompressible. So in other words, if you really squeeze on ice, you will not change the volume or the shape. So again, these are the definitions of matter. I won't be asking you to give me the definitions of matter. What I'll be asking you is, once you understand these definitions, can you now apply these definitions to solve different problems? Okay, I think I have some here. So here is a question. Which state of matter is essentially incompressible? Notice I'm underlining these keywords, and I'm doing it deliberately to make sure I understand the question, or the key aspects of the question. The key aspect here is what state and essentially incompressible. Okay, so again, let's go through this. So let's start with the bottom. A gas, a gas is compressible. Okay, you can squeeze the balloon and you can even pop the balloon based on how much pressure you put on it. A liquid is slightly compressible, as we said earlier, slightly. But a solid is not as compressible as the others, to the point that it's considered not compressible. So let's see what my answer is. And this is no surprise that the answer is let's get a pen, is a solid. So again, as you study along with your textbook and these lecture videos, be able to apply the definitions and the concepts that we're going through. You won't be asked to reproduce them, but you'll be asked to apply them to solve different problems as we're doing in these examples. Okay? All right, let's see. Okay, we'll stop here because the next lecture we'll do density, but we'll stop here for this lecture. So once again, go through and continue reading in your textbook, and as you read along and you watch these lecture videos, make sure you have your calculator right beside you. Make sure you have a piece of paper and a pen right beside you, and make sure you have your periodic table. We haven't used it yet for this lecture, but you will use it before too long. Make sure those are your tools, as a chemist. So make sure you have those whenever you come to work. And of course, work for you is learning the chemistry. Okay, so continue studying, and I'll post the next lecture video shortly. Okay, bye.